contaminated. Yeah, it was actually.
It's fine.
I was going to mention some other stuff about it.
Okay.
Okay. Yeah, let's get over this. So this paper is about bio stuff. This time is tissue engineering. So let's go over this again. So as I said last time, every biomaterial paper's goal is about save people, save world. So last time we tried to save world about the environment. This time we save people. They wanna use the PLC plus the vaccine to replace some tissue in people's heart, like the cardio part. But they don't use cell from heart. Instead, they use the cell from the upper skin. So I really don't know why, and I really don't know why they think this would make them succeed. But
Maybe it's hard to find heart tissue.
What?
Maybe it's hard to find heart tissue.
Yeah, but they don't use the heart tissue. They use the
The skin tissue is what you're saying for like a heart?
I don't think so.
Well, for like skin cancer in your face or whatever, they use skin from like your legs and your
Oh, that makes sense.
grafts and stuff.
Yeah. Because they use the epithelial cell.
What?
Epithelial cell.
Oh, okay.
Yeah, I don't think in the heart, some part of them is called epithelial. But yeah, that's the first part. They wanna this time save people, make the new tissue. So the important thing is to think about the biomaterial. If you wanna put them inside people's bodies, think about their cytotoxicity and biocompatibility. There are two things that about first, if your material is toxic or not, because if it is, I don't think you can put that in your body. Or if it's not that toxic, maybe your body can figure it out. And then the second one is if this thing binds well to your body. This is really important. For example, for the plastic surgery, if you want to make your nose higher, usually if you put some silicone stuff inside your nose, you will have a very, very severe reaction because this will not bind with your body, because your body will think that this something goes from outside, then the whole immune system will try to fight for it. So the best option now is take a bone from your ear and then put it in your nose. So I once heard some girl said her boyfriend loves her so much and he gives a bone from her.
Hi. I did not know you guys were meeting here because this room was reserved for MSC for the whole day.
Oh,
Yeah.
sorry.
We're MSC. Wait, MSC is in what do you mean?
For something for today.
Oh, yeah. Okay.
Is this not the room Sakshi bar?
I don't think so. I think this is a different room.
Oh, okay.
That's okay.
But we're here now.
We're
And
MSC.
she left.
As I said,
She didn't tell us to leave. She did not tell us to leave.
It's
She
okay.
left.
Yeah.
Alright.
Yeah, okay, so once I heard the girl said her boyfriend loved her so much and he even gives one of her bones for her nose surgery. You know, I think her boyfriend wanna kill her because she will die. If she really wanna live and she do not want hurt from a bone from her ear, take her brother's bone. You know. Yeah.
Something closer.
So that's because then the biocompatibility will be well. And then the some basics about the cell membrane. So as we know, the cell membrane, there are two parts of the cell membrane, the head part and the tail part. So the head part is the head part is very fond of water, so it's hydrophilic, and the tail part is it do not like water, so it's So they will be together like this. So the head will be outside, then the tail will be together to form the whole membrane. And that's some basic stuff. And on the right is a whole success of how a new biomaterial will finally be put into use. So first, they made the biomaterial and then they do the virtual test. If virtual test works, then we do the vivo test with bacteria or some small mammal like mouse, and then they do it with some large mammal, then finally primate, and then finally they find a volunteer. That's why you get paid, because, and finally if the FDA approves it, then it will be in use. That's the whole part. So based on all this, I don't think this paper may make sense a lot, but maybe I just don't understand. So let's say it. So yeah, so the goals of this paper is to use an immobilized vaccine in several layers and on the electron spin PCL membranes, and then use all the all the analysis, all the techniques to try to figure out if their new biomaterial is good or not. But the thing is, if that material wants to be used, it has to be, as I said, almost they cannot be toxic, and they have to be bind well with your body. But the thing is, I don't think they prove this thing very well, and I will explain it later. And also, this whole paper lacks a lot of logic, because compared to the last paper, the paper 3, we already discussed about. In that paper, I think they talk about like, first we get a new material, and then we measure their mechanical properties, and the mechanical property is great, then we want to figure out why. That's why we do the XPS or the FTIR. But for this paper, I think the whole paragraph is like, we did this, we did that, and then the result is like this, the result is like that. But they never said why they did the whole kind of thing. It's like, maybe they just have time to do all the material, but they do all the calculation for their material, but I don't know why. So in the paper, they said why they use the vaccine. It's like vaccine is a very great 2D nano material with high electronic and ionic conductivity. So they said if they put this kind of material in the heart, and then maybe they will be good for people. But the thing is, in that paper, I believe so, when they are talking about carbon material in the introduction part, they just said carbon material is not that good because because of their let me check. Because of carbon material are they do not degrade. And then they suddenly said vaccine is good, but they never said can vaccine degrade in your body or not. So why? I really don't know. So, and in the paper, I believe they did not explain why they are using PCL. So still, they just use PCL, and I don't know. I do not find it, and they also do not say is PCL biodegradable or not.
What is PCL?
PCL is
Caprolactone?
yeah.
Oh, okay.
Yeah. So yeah, that's really confused me. It's not like paper 3. They explain everything to make us believe their choice of material is the best. But this one they just pick up some, but I don't know why. So it just yeah. If you have different opinions to share, then it's great.
I mean, I think they just wanted to choose a polymer that was like a good dielectric that's also been shown to be biocompatible.
I mean, PCLs are very commonly used biomaterials for artificial membranes and stuff, right?
I think so, yeah.
So I think that's why they use it.
Yeah, but that part makes sense, the vaccine.
Yeah, why they use, like, if they know the vaccine is compatible or not.
Conductivity,
Yeah, for conductivity.
but yeah, they still should say why it's compatible, if it's compatible. I don't think it is.
Yeah, I don't think they know that.
Yeah, did they explain clearly why the vaccine is over other 2D materials?
Conductive.
Like why
That's a
why
good
don't
point.
they use graphene? I know graphene cannot be put in the body. I just ask.
But they say it's carbon based, it's okay.
That is what they say. They do say it's carbon based and okay. I don't know.
Yeah, that's
Yeah, they don't really say that. They literally just say a new family of 2D materials have demonstrated promise for biomedical applications.
Yes, yes.
That's all they say.
Yeah, but they never say why they are promising for biomedical use.
Yeah,
But
weird.
I know, but it's okay. Yeah, let's go through it. So there's a PCL and they try to cover it with vaccine. So from 0 to 4, they cover it with more and more vaccine, so the color became darker. So that comes to my next question: why they are just vaccine 1 to 4? So like after they do them like 4 times, then that's okay.
Wasn't that what you were saying?
So yeah, I was also really confused about this. I read that as the number of layers.
Yeah. So why just the 4 layers of vaccine? Why do they do on 100 layers?
See, that's a great question, because a lot of the conclusions they make based on layer thickness are pretty variable and have lots of error.
Yeah.
I don't understand how they can get even, like, based on the SEM images, not those, but like the ones in the next figure with the EDS, it doesn't look like even coverage. So I don't know how they know for sure the values that they're getting in one particular area are representative of the entire sample.
Yes.
So I don't know.
I don't think I'm gonna do this paper. I have no idea what's going on.
It's totally fair.
Yeah.
Bye, see you later.
Good luck, you guys.
So that's the question. Why they just make 4 layers of vaccine? And here are some calculation part. They showed the vaccine part and try to verify they successfully put the vaccine on the PCO part. And and then they do the SEM. That's
Yeah.
that
I agree with your question mark statement.
yeah.
Ew.
I really don't know why they suddenly comes out this kind of conclusion. And
So bad.
in the whole paper I tried to find it for several times. They even not talk about the difference between these two SEM. They just said, we did SEM. Here's the result. And what's the
They
difference?
mislabeled one too.
They did. We found that in the
very
TI,
first one.
the bottom one has two
It's two
TIs.
titaniums.
One's supposed to be fluorine in the 4th layer. And the EDS spectroscopy stuff with the C and the O and the T, look at the error bars for that.
Oh,
For the titanium, plus or minus 2, 4, 3, that's almost the same amount as the value they're getting. Completely useless. And they make the claim that based on the titanium levels, we can say that
because
there's
then-
more layers.
Yeah. So I really don't. And what's that for SEM? Did they mark the bar how big this is?
Yeah. They have the, it's in the bottom left-hand corner of each image.
Did they tell you what the number is though?
Did
In
they?
the caption, it should say.
Scale bar 10 micron.
Oh
Pretty big.
10 micron?
How are they doing EDS on 10 micron?
You can do EDS on 10 micron.
Not well.
Well, look at those images. They're not good.
Yeah.
They're terrible, actually, I would say.
Mm-hmm.
Like,
You're
the
the SEM
titanium, I wouldn't say I'm an expert. Todd is the expert. The titanium, if you look at the bottom left,
Send this to Todd.
we could send this to Todd. We could ask Todd.
We could ask Todd.
So in MCF, Todd, he's the guy who does all the SEM stuff. We love Todd. He's the best. So maybe we'll ask him what's going on here. Because these look like crap to me, and I wouldn't say that you can make any conclusions on what has, because usually you don't quantify, you do like ratios. So let's say you have a metal that's like a 1-to-1 composition. You'll
like
use
XPS
EDS.
or something. You'd always use ratios.
Exactly. You're never going to be like, oh, there's 0.1% more titanium in this, so
no,
then I
it's,
can
I
say
have 2 times than that.
exactly.
I know,
That sort of
I know.
thing.
So
Like,
you don't
this is
usually
just
use it like
weird.
this.
Okay. Yeah, no, I've done a lot of EDS in the past, so I haven't really read this paper and know what's going on with the EDS. I guess I'm just trying to figure out the thickness of the. They're relating the amount of the titanium.
Just the elemental composition.
Yeah, that's
As
what
you
EDS
increase-
tells you.
As you increase the amount of layers that's going on, is basically what's
Yeah.
happening.
So with the Maxines, you have titanium in them.
Yeah.
So they're saying if you have more layers of Maxine, then we should be getting more titanium signals. So all EDS does is put energy into your sample, and then it'll spit out energy wavelengths that are specific to the type of atom present.
Yeah.
So for titanium, you're going to get a specific peak. For carbon, you're going to get a specific peak. Oxygen, specific peak.
XPS, but bigger.
Exactly. So, but it doesn't tell you orbitals. It doesn't tell you anything like that. It just tells you what's
It's
the atom.
very blurry.
It's very blurry.
Yeah.
It works for heavier elements. For lighter things like carbon you can kind of tell.
If
But-
they're distinct enough peaks,
Yeah.
and there's a range for how
But-
much energy you're shooting off of it, what you're going to get back.
Fluorine, questionable. Nitrogen,
Oh, yeah.
questionable.
Oh yeah. I remember
So I don't super trust because they also make the claim that the fluorine, the fluorine increase also shows that more Maxine was present.
But then doesn't it have like kind of like a depth scale at which how thick are the layers that are being put on?
Yeah. They could be just blasting through it too.
They probably are.
Because you know how much you hit it, and it's still X-rays. and
Yeah.
stuff coming, penetrating into it and coming out. So yeah,
So because this is just the penetration depth of an X-ray, and that's going to be the
I
same.
need to know if they're consistent.
That's the thing. You'd have to increase.
They should be. If they're not,
Yeah.
then something's really wrong.
Are they trying to increase the energy with every like
They should.
layer that they're
They
putting
should be
on?
the same. Because if you think, like, let's say I'm cutting into a piece of cake and I increase a layer of frosting on the top,
Yeah.
I'm going to cut the same slice of cake. I'm not going to change the depth because I want to see how much frosting is changing from each slice. So I'll cut the same slice of cake each time.
But
Or maybe it'll be the same layers of cake. Do you know what I mean?
what I'm saying is like how
How's that
far
not?
does EDS penetrate below the surface?
How far
depends.
X-rays?
How much you shoot it, it's still like an SEM is what you do this with. So it's an electron gun.
Okay.
And you tell it, I want 5 keV, 10 keV, depending on what you're looking for. If you're just looking at the top surface, then you do something less, I think.
Okay. Because
And
it's-
also depending on what atoms you're trying to look for.
what I'm thinking is that as they're adding layers, does it get to a point where they can't reach certain layers that they initially deposited? Or
No.
You could.
Yeah, you could, but not with this.
I don't think with this.
Maxines are pretty thin.
okay.
Yeah.
I didn't know how thick
It's
the
just a
layers were.
weird. They're 2D materials. So they're nanometers. It's just a weird way to show how many layers they have. However, I don't know how else they would do it.
Well, they do it later on. They do IR.
Okay, that
Which-
just tells you what the material is, not the layers.
Exactly. So that doesn't tell you layers. And
'Cause-
they do XPS.
That also just tells you the top layer.
Exactly.
So what we do to figure out how like how tall our 2D material is we just cover part of the substrate and it just masks it off basically.
Right. And,
Okay.
We'll just keep quiet.
right.
Yeah. And then you can literally take an AFM, measure the height of the thing,
Right.
and that's as accurate as you can get.
I don't think they can do that here because the surface
And I
is so
don't think
rough.
they can do that here because it has the PCL and stuff in it.
But how do you come to the conclusion that the vaccine is not homogeneous?
That it's not homogeneous?
It's in the paper, but I really don't know.
Wait.
Isn't it like the brightness of the graphs that, or not the pictures that you get? So if you have like little dots all over the
Yeah.
place, then that's what like heterogeneity is.
Yeah.
So you have higher concentrations of titanium in certain regions or whatever compared to other regions. So like, you see how like, say this titanium here, how we have like these bright spots of yellow,
Yeah.
right? And because of that, we can assume that this region is high concentration titanium compared to the rest.
And this
I don't know
like
if
have a
that's
dark.
And this has low concentration
Oh.
titanium. That's why they
This
see it as
reflects that
heterogeneous.
Maxine
Oh,
was thin and not
okay,
homogeneous.
okay.
Okay, so they are saying it's not homogeneous.
That's
That's
fine.
good. I agree. I thought they were saying it was homogeneous.
What are those fibrils? I don't know. I didn't
That's
really
from
read
the
this paper.
PCL.
Oh, okay.
That's the PCL substrate.
So normally a 2D thing would be, flat,
Super flat.
super flat.
Yeah.
And that's why I can do my little step edge thing. But this, like, what do you call the top layer? Like, it's not flat.
Okay. Alright.
Okay,
I hate this
continue.
paper a little less now. I decided it was not.
Okay, yeah,
I
and
don't like that they use that.
No.
yeah, and then they do the TM, and I think it gets the same conclusion as SEM. They just try to figure out where exactly does the flakes of vaccine coat the PCL fiber.
See, now this also bothered me because look at how many layers there are. That's more than 4.
Yeah, this one is.
What sample is that from?
Yeah, how did they define this is layer 1? Like what?
Okay, so there's I forget what the thing is, the XRD thing is with the dots. But I think they're saying because there's 2 dots, there's 2
fraction
layers.
pattern?
Yeah, well, yeah.
Oh,
That
because it's
still just
paired
tells
like
you-
that.
Yeah,
Oh.
because they said there's an 8 degree rotation between each layer.
Okay.
So then you'll be able to see 4 diffraction.
Yeah, there are 2
Okay.
layers. So
That's the better way to do it. That's what they should have done and not even bothered the EDS. But, okay.
and
Why
about
would
that
they do
figure,
for
it's
EDS?
like
That's really stupid.
Mm-hmm.
That should have been supplemental. They should have done it, but it should have been supplemental.
yeah. And so what I don't understand is for this one, they have a lot of layers. What's their purpose?
Show you that there's layers, but shouldn't it be 4? I would like there to be 4. That would make me feel better. And then they say this is the 4 sample.
But it's not for.
I know.
I think it's like.
So what sample is this?
Multi-layer flake. Whatever multi-layer is, that's what it says. On
Why do
the
we care about a
description.
multi-layer flake?
We don't care about multiple. We only
Maybe-
care about 1 to 4.
Oh,
I think they wanted to see the thickness and the spacing of the things.
It's
Yes.
probably just the prettiest picture they got and they want to put it in.
Yeah, it's so
Okay.
pretty. No, yeah.
Yeah, I thought maybe they want to say
Done
like
that.
we can do more layers, but we just want
But
to
we
show
chose
1
not
to
to.
4.
And here's
yeah.
our prettiest
Yeah,
picture.
maybe.
That
Okay.
shows layers, because we probably got a whole bunch of crappy ones that don't show any
Okay.
layers.
Yeah.
Yeah. and
Look at
then
you.
That's a.
Oh.
Yeah, that's that's the FTIR and about all the things they can get about what HP stands for, which
Ooh.
chemistry moieties.
You probably just answered your question right there on the exam.
Although isn't OH? I thought OH was usually the broad peak at 300.
300.
Not the CHs are usually in the lower. I will double check myself before I say things I don't fully know.
That's in the paper. So they said OH is 1395.
Oh, it's already in the
So
paper.
Yeah.
That's already in the paper.
Yeah.
That's such a-
Is it
OH
secondary?
is 13. Yeah.
What the fuck?
It's a.
I don't know what that to. Cool.
Did you?
I will look more into it.
Yeah, I don't know. If,
Oh, OH bending vibration. Okay. It's not actual
Yeah,
like
yeah.
H bonding.
And you're referring to
Your
which
thing.
one? The one that oh,
Uh,
only OH on there. Okay.
Yeah.
Thank you. Sorry.
No, it's okay. Yeah. So after this, that's why I hate most. They do the XPS, but I think there is a lot error in his paper. So
Heck
yeah. So in the
Very
paper,
nice.
they said that titanium is like 450. It's not 450.
Oh.
It's not?
It's like more than 500. It's like
Oh, they say. Oh.
550.
What happened?
Oh, shit.
Yeah.
Oh, shit.
That's a and also the
Bad job.
and also the oxygen.
Oh my god.
They didn't report their
They
graph
marked
right?
it where O1S should be flipped with TI2P
Oh.
according to their graph.
Yeah.
Wait, where do you get that flip from,
Oh
or?
my god. This paper sucks. Look at the scale for the binding energies for
Oh, yeah.
TI and the oxygen.
They're calling TI2P O1S?
Yeah.
Oh my god. Who wrote this paper? They
Yeah.
suck.
Yeah, and also when they are
Oh, yeah.
when they are talking about the high resolution part, it's 5C, and in the paper they said figure 5B. So
My god.
Oh, wait, I still don't get the flip
is
thing.
wild.
This is why we're
What
like,
is? What do you mean it's
they're
flipped,
gonna have us
Clary?
trash this paper in the questions.
uh,
Why is
Holy
the paper
shit.
bad?
But the thing is, like, maybe a professor proposes paper just so
Because-
you be like,
So bad.
where, you know,
This-
what's wrong.
this titanium
And that's my
in
favorite
the
part
paper
paper.
they said it's 450, but clearly it's not 450. This is 500.
The ONS is 450.
Yeah.
Oh, did they say the ONS was
Yeah,
550?
yeah.
They said the ONS was 550 too?
Yeah.
Holy Moses, okay.
Yeah, so
Wait, we could just look up that value online just to see what's actually right, because maybe they mislabeled everything. XPS 01.
You could also ask Cooper.
535. Yep. That's correct. That's O1S.
So they labeled it wrong in the A?
They just labeled it wrong in A. That was
It's
their
really
mistake.
bad.
But that's pretty bad. That someone should have caught that.
yeah,
That's
yeah.
a big mistake.
Okay, well.
Yeah, and
Love this paper.
yeah, and what I don't understand is just after they talk about this figure, they said it's still on page 5. They said no titanium 3 plus component was present in the case of PCL MX1 sample. Why?
It's a great question. It should be there, right?
I know.
Mm-hmm.
And also after this, they said in the case of this PCL MX1, additional component at 536 was detected and assigned. What are you talking about?
Oh, there's this TO peak,
TIO?
peak, in the oxygen. Is that what it's saying?
Oh.
In D, there's a CO, there's a C double bond O, and then there's TIO.
Okay, yeah.
Okay,
Okay.
that's not that
Just
interesting.
made a doublet
Okay.
because it
Maybe this is a function of me not reading this paper, but what are they trying to do with all of this? They're just trying to see what's there?
They're trying to prove that their Maxine is on this PCL thing.
Yeah,
And how
yeah.
many layers are there?
Yes.
And the
And
Maxine
this-
has titanium.
And this relates to how many layers there are?
No,
No,
the
not
XPS
this.
just tells you that it's there. And
It
that they have the
should.
right elemental compositions, like the right formula, chemical formula there.
Okay.
They're just trying to show that it can code it
Yeah.
good,
Ah.
but it's not good.
Well, they already said that it's like heterogeneous from the EDS. So.
Yeah. Oh, okay.
Yeah,
Then.
Well, they said it was non. Yes. Yeah.
Yeah.
You're right.
Okay, and then here comes my favorite part. Maybe.
Well, this is the part that kept me away from this paper. I'm like, I'm tired. I do electronic materials. I don't want to read this.
Yeah.
It is electronic.
But where is it?
Okay, yeah.
Oh,
So
it's
about
literally right.
figure 6, there's a super interesting part, and if you look at page 5 on the right corner, it said clarifying the sources of these oscillations will require additional study, which is beyond the scope of work. And they just said they said themselves they're the result of their experiment is crap, because they said because we for the left part about this part they said there should not be the oscillations, and their result have, so that means their result cannot stand for it, and they didn't try to figure it out and try to make a new experiment. That's here.
Is there a reason they tested within that frequency?
Let me think.
What is this then?
So they proved
Measuring capacitance.
the they proved the capacity decrease with the increase of frequency, and they also said there is some
As a result.
fluctuations during the
Oh.
10-4 and but they never explain it, so maybe some of you know.
So they're trying to get a conductive material on the
Mhm.
polymer, and that's why they're doing these tests to try and see how conductive it is,
Okay.
sort of, or like if it holds charge or something, for
Yeah.
instance. And then it didn't.
Oh,
I
so
think.
wait. So you have the Maxine. Is that the thing that they're trying to?
Yeah,
That- and they-
Maxine is the 2D material that's super conductive,
And it's
Yeah.
like two birds in one stone, basically, because
Yeah.
okay.
and that's why they want to use it for heart material, because electrical pulses in your heart and stuff.
Oh,
So-
but they're saying that it also doesn't conduct well or something.
Yeah, I don't know how to read this necessarily, but I think they're.
I don't know either.
I mean,
Oh.
capacitance looks at a frequency response, so how fast your material can respond,
Mm-hmm.
and you want fast because quick communication between things. I'll have to look and see. So their capacitance just drops, so they go to higher frequency.
Yeah,
So it's
but-
not holding any charge.
Yeah, but
So you
they
get fast.
do not like drop smoothly, like they
Mhm.
have some fluctuation, and they didn't
Yeah, that's weird.
explain why, and they also
Mhm.
said this part is it's bad.
Mhm.
Their exact word is the oscillations here
Should be 0.
completely distort their measurements,
Okay.
and I don't know why they mention this thing, and then they never try to figure out why.
50 volts per decade.
I don't know.
50 points per. However, after all that, they do say that there is both capacitive and inductive components in these layers.
Sure, but it's crap once you get to higher frequency, I guess. I mean, I'd have to look at this more.
That's the best one too that they saw.
Okay. Which is probably because it's not homogeneous.
Yeah.
And the polymer properties are coming through, which doesn't want to conduct anything.
Mm-hmm. Well, what also bothered me is that they say that the conductance and the inductance, the capacitance and the inductance would improve with increased layers.
Yeah.
But then they also say that increased layers decreases surface attachment.
So they expected an increase in properties, but it wound up being a piece of shit.
Yes.
Yeah.
This whole
Oh.
paper is a
I
piece
think
of
so.
shit.
Oh, okay.
It really is.
I know. That's why I said their lack of logic.
Okay.
Yeah.
Layers. What's
Yeah,
good about two? Are these? That's just 2D layers. Is it 2D layers?
Yeah.
There's no how the fuck. There's nothing going on between those things.
Yeah.
There's no contact. It shouldn't have been good at all.
No.
Well, it wouldn't matter necessarily if you're just looking at like.
Those are
It's not adherence of the Maxine to the PCL.
It's
maybe
Maxine.
No, adherence of the cells to the Maxine and PCL combination. So once they prove that the conductance was good, then they move on to cells interacting with this material.
Oh,
Yeah.
this is that.
That's not this.
Okay.
This is just
Okay.
electronic, whatever.
They did move. Yeah.
So there's more stuff.
There's more.
Yeah.
But there's
Yes.
things that even within the Maxine that's bad.
This
Kind
is
of.
still on the PCL.
Oh.
Yeah, they just choose their PCL Maxine 3 because they said because clearly PCL Maxine 1 and 2 they don't work. They are non-conductive, and 3 and 4 work, but they think 3 is thinner than 4, so they choose 3.
Okay, but then you say something about insufficient direct contact between overlapping flakes.
Yeah.
Is that the flakes, like the sequentially deposited Maxine flakes?
Mm-hmm.
So that's what I'm saying, is that like the flakes themselves have bad electrical properties.
Because there's not enough of them.
And it's
Because
not
there's
homogeneous.
enough of them.
Yeah, that's what they're saying. There's not
Oh.
enough that are overlapping each other to make
Yeah,
conductance
yeah.
or
Yeah.
electronic things happen.
Yeah, it's kind of like those synthesis papers, like the WSC2. We wanted the large grains
Mm-hmm.
so that it is better conductive
Yes.
and is a nice homogeneous layer.
Mm.
This is anything but a nice homogeneous.
Mhm.
Yeah, they said based on this, the capacitance should be 0, but from their result, clearly not.
Yeah.
I don't know. They already actually I think even in their paper are crap, but they have clear knowledge of themselves. They already said in the paper about their disadvantages a lot. So
Yeah.
they are brave, at least.
So it's like overlapping flakes. It's not that they're not growing on. It's not that the ones that grow on top of each other and overlap don't have bad contact. It's that there's not enough of them overlapping, and that kind of shows in the EDS because there's a ton of like spots where there's a shit ton of TI and like a shit ton of other elements and stuff like that, and that kind of like, can that relate to the overlap, like the lack of overlap?
Yeah, I mean, there's just with like the one comparing 1 to 4.
Mhm.
1 has 1 layer, 4 has 4 layers.
Okay.
Therefore, there are 4 layers. There should be more titanium than in 1.
Yes.
That's the point they were trying to get across. Not necessarily knowing how many of those layers overlap.
Mm-hmm.
They're just saying 1 and 4 as that's what they're assuming the average overlap layer number is.
How are they
I see.
contacting to these flakes
Great question.
to measure the
Yeah, I don't know.
It is a good question. I mean, because with flexible materials, it's really hard to contact them. And
in 2D materials? They don't want to stick.
so it just sounds like a bad combination.
But contact me like measuring these things.
like
and
putting
shit?
Yeah.
little like
Probe tips.
gold contacts on there to
Oh,
measure
like,
stuff.
like a 4-point probe or something like that.
Yeah,
Yes.
but
Oh,
like,
yeah.
how are they getting it right where they put the EDS and all that stuff?
Oh,
and like,
yeah.
how are you gonna say, okay, this is 4 layers and like, yeah.
We can keep going, though.
Yeah.
It's okay.
Yeah, okay, and and then finally they wanna show their their stuff has a longer lifetime, I believe. But the thing is, what I don't understand is why this figure has two parts. Why this has two parts? What's that?
Silver paste.
Like-
Silver paste.
Oh, silver paste? I don't know about that. Okay.
Interesting.
Do you use silver paste? Isn't
It's
that?
pretty inaccurate and pretty large.
AC measured June contracts at the end of the night. Oh my god.
Because they did a lot of stuff in cryostat too, so they have to.
Interesting. Okay.
Yeah. Okay. Continue. Sorry.
That's weird.
Yeah, so do you know why this figure has two parts?
I don't remember
Oh,
this
it looks
one,
like it
to be honest.
has IT, like whatever
I don't know
tau
what
1 and tau 2 is, and then I1 and
Positron
I2.
light.
Yeah, I know,
what
yeah.
that is.
They
What's
get
a
a kind of a equation. So
Basically.
tau 1 and tau 2 is about their
I
life,
don't look at it.
different lifetime,
Positive electron.
and they have the model
Oh, yeah,
of
and they positron.
interaction of
What is
both
I? And what
this.
is tau?
And
Time.
Wait.
the thing I think based on their explaining the maximum 4 should be better, and yeah, it kind of proved it, but why the other 3 has such a weird lifetime? Just why the lifetime of
Oh.
4 is totally different from 1 to 3.
I think so. T1, T2 are different defects, and
Defects?
like in the model, they use two different models to interpret the positron lifetime. In the split, one works with time 2 and then time 1, and then in the intensity, they look at the defect or whatever. They use defect and positron. I can read the sentence. To interpret the results, we use the model positron captor and polymer with one type of defects, with one type of defects and T2 and
Or
I2.
tau 2, I2.
Okay, so it's one defect, but I don't understand what the other one is.
I don't know what positron annihilation is.
We should probably just find someone who knows. Google would know.
Oh yeah, since you're reading that paragraph, so is there another mistake? They said the intensity is decreased from 21 to 10. Figure 7b is actually figure 7c, right?
Nice.
Yeah.
Really?
Yeah.
Somebody didn't check their figures very well.
Someone did a bad job. Equation.
You're saying that each of those lifetimes has to do with a defect?
No, don't listen to me. I don't know what I'm talking about.
Okay.
That's what I would think.
That's what I thought, but I have no idea. I know nothing about
I
this.
still don't. I wouldn't understand how that would work. Because, yeah.
I mean, positron is positive electron, sort of, kind of. So I think it'd still kind of be a conductivity thing. How long does it stick around? But I don't know. And, you know, you could run into a defect or something.
Okay, maybe we'll look more into this. But I mean, the end results from this I'm getting is that the results don't make sense to me. Because for the lifetime in nanosecond, I would think the trend would be trendy for increasing Maxine layers, but it goes one is the lowest, the brown. Look, the A. They're all in different orders than what I'd expect. Like, why is the thickest Maxine have an upward trend with temperature and lifetime?
Exactly. Yeah.
Like, what model is that? Like, I don't understand. It just doesn't make sense to me. And then they try to make the claim that, like, they try to explain why all these things are happening. Doesn't make sense.
Yeah, I know. I just don't understand this part, especially.
Oh, did they shoot positrons then?
Did they?
Oh.
They shoot. Or maybe let's come back to
radioactive
this.
then.
It's
Okay.
radioactive. Okay,
Mhm.
let's come back to this because I don't understand.
Okay.
We're not gonna understand now.
Yeah, and the
Contact angle.
yeah contact angle. So if it's lower, then it means it's hydrophilic, and higher means it's hydrophobic. So they
It's my
measure
favorite part of the
their
whole thing.
contact angle. But I believe last time they said because Maxine 1 PCL MX 1 and 2 is is not conductive, while 3 and 4 is good.
Yeah.
And this time 3 and 4 is not
I
good.
know. I love it so much.
So they just like refuse their own experiments, whole experiment. So that means their 4 samples totally fail. Okay, and last they show the results of what's.
Oh, I also want to add for that last thing, we concluded that excessive deposition of MXC in more than 3 layers could increase the surface roughness, which might affect the contact angle and make it stick better, which you showed in 4 does not.
Yeah.
So they think if they add more layers, it'll increase.
Can you read that sentence?
So why didn't they just do that?
Page, I don't know, what page is this? It's on that same page as the graph, right hand, top right hand paragraph.
How are these layers being deposited?
Colloidally. So they take some sort of chemical solution. Well, I think they like ground up the max phase, stuck in a chemical solution, and then it's supposed to stick.
Holy Moses.
Yeah. It's not. But that's because they have the polymer. So it's not like a normal way.
Yeah. For me, the figure 9F is not good.
Yeah, it's not a good way to make a good 2D material.
They claim that the positron annihilation demonstrated that the density of nanoscale defects increased with the increased number of Maxine layers. So that also could have affected things.
Yeah.
Apparently they were inverse. Apparently that positron stuff showed something.
Look at me.
I don't know.
Good questions they would ask from this paper.
Yeah, I know. So I mean for this last paper, so
It's okay.
they want the purple dots to be more right?
Yeah.
And the last one just I don't think have few dots.
I love this as well. It's so good.
Okay,
It's so shit.
Yeah, so that
4
proves again
is
the
the same as good as none.
Yeah.
So bad.
Just use the PCL.
I know.
So bad.
Yeah, I think for the whole figure, the third one looks. I mean, it looks okay, but just as I said before, they said for the contact angle, I don't think the third one is okay. So yeah, that proves their whole experiment is a failure.
Woo!
That's okay. Failures, as long as they do them right, are good.
I mean, also as long as we can explain why they
Exactly. That's
failed.
something if they did it right.
Yeah.
But the conclusions are all over the place.
Okay.
Okay.
Yeah. So I think it's